Hello everybody, and welcome to this pop-up geology event at Sentinel Gap and the Beverly Railroad Bridge. Well, wait a minute, I got to speak louder because, hey man, we got a party here. Look at this, we got all sorts of folks. Oh my heavens. Cue the music, Kyle. We got a ukulele. We got everything here. We got a wonderful turnout on this beautiful evening, and yes, I'm going to be talking to these folks here, but this is a recorded thing that will be put on YouTube tomorrow. I'm not sure when, but probably tomorrow afternoon. So if you want to watch this recorded video tomorrow afternoon, there'll be a live chat and people from around the world watching. Speaking of locations, I think I already know our winner for a visitor with this particular thing. Adventure Sombrada from the island of Oahu happened to be here and is joining us. Yeah, man. But let's hear some other locations. Where did you come from, please? Wenatchee. Marysville, Washington. Huh? Vancouver, Washington. Desert Air, Washington. Cle Elum, Washington. Salem, Oregon. Spokane Valley. Yakima, Washington. Selah, Washington. Wonderful. Seattle, Washington. Terrific. I'm glad you're with us, and I'm glad you're all here. This is a pop-up geology event, the third one that we have done this spring, and I like the format, so I want to remind you what the format is. I will continue to kind of spin these folks around at home. In fact, it might be you if you watch this tomorrow. But I want to just give people a sense of the location first of all. So I'm reminding you I'm going to be descriptive on purpose. I'm going to be disciplined with place names and elevations and that sort of thing. Just to lay the groundwork, because we have people watching from around the world. So we want to give everybody a chance to make this all happen. And then we will get into some geology, and you're like, oh my God, how long is this going to be? This guy's just going to stand here and talk like there's nothing else? That's right. About a half an hour, 45 minutes I'm going to be talking, and then we'll do 15-20 minutes of live question and answer, and I'll make sure to repeat your questions so that people at home can hear what you asked. I'll do my best to answer, and that'll be it. Some of you have been walking on this beautiful bridge already. Others might still have enough daylight to go enjoy the bridge after we're done. That is the historic Beverly Railroad Bridge. Let's give you some other landmarks. Obviously the feature here, let me pan up, can I do that? Is the Saddle Mountains. Elevation at the top of Saddle Mountains right here, 2,200 feet elevation. 2,200 feet up high. We are at about 600. Down low or maybe below 400 feet elevation. So we have 1,500 feet-ish of elevation, not only on this side of the river. So we are home viewers, and most of you guys are looking south. We're looking south through this hole in Saddle Mountains known as Sentinel Gap. That's the star of our show today, Sentinel Gap. We'll talk about why that hole is there, what all has been going through that gap in the Saddle Mountains. So Sentinel Gap, yes. So looking south on the right side or the west side of the river, that's Kittitas County. And the Army, the U.S. Army firing range, that's that land up and over. If we swing off to the east, we go to the other side of the Columbia River. Yeah, this is the Columbia River right here. That's the Grant County side. Little town of Beverly is right down over there where the bridge is leading. We have some campers over in Beverly this evening. Some of them walked across the bridge to join us. Behind you is Vantage, Washington. A few minutes. You all went there, I know, because you had to drive south on a dead-end road. What was it, 10, 15 minutes to get down here. How many brand new to this spot? Never been to this spot before? Almost all of you. Okay, that's terrific. So it is kind of a cool spot, and we have a rare chance to get a nice view of this impressive north face of Saddle Mountains. That's what I really want to focus on. In fact, even though this is enticing right here, much of what I have to discuss with you is not this face, but the face that's across the river. As we look past the power lines, as we look across the Columbia River, that's what I refer to as the north face of Saddle Mountains, and Crab Creek Road is right along the bottom there. Many of you have been along that Crab Creek Road, and you can see as you look up on that face a number of rock layers. Those are the rock layers we are discussing today. Many of those rock layers on the east side of the river do not really show up nicely on the west side, so it's not a pleasing one-to-one. You can't see that layer and then follow it across. They're here in many places, but they have a different appearance, and we may or may not be getting into why it looks a little different on this side of the river. Okay, camera boy, just quit screwing around now. Just get it nice and steady. You don't have to keep panning up and down. Talking to myself. Okay, great. Boy, you can hear a pin drop with this crowd. I don't know how many we got. 150? I don't know. It's like a full parking lot. It's just a thrill to have so many out here on this. We've got a few raindrops, but otherwise, we good. He pauses for dramatic effect. That's right. I got to go into my back pocket. I got to get some notes. So let's see. Yeah, okay. So to remind you, these pop-up geology events are using the view that we have, and that's all. It's in living color. We're all out here together. There is no green screen. There's no chalkboard. There's no whiteboard. There's no animations. There's no handouts. There's no maps. It's all just verbal. That's the design of this whole thing. And I've forced myself to get down to one piece of paper for notes so that we don't go crazy out here, okay? So, I'm reminding myself, yes, I've done that. Yes, I've done that. Good. We transition to geology. And we're going to tell the geology stories in order of appearance. In our field of view, what's the oldest thing in our field of view? River. Very good, students. Many people said the correct answer, which is the Columbia River. The Columbia River is the oldest feature out here. Older than that ridge. Just think of that for a second. We have evidence that this river used to be flowing through this area before that ridge formed. You can't form the ridge until you form the layers. Yeah, I'm saying the Columbia River is older than each of those rock layers. The Columbia River is the oldest feature in this field of view. So how far back do we have to go? And are we just going to talk about the river and the rock layers? No, we'll get into the Ice Age floods. We'll get into a bunch of other things. But we're going to start our story older than 17 million years ago. Older than 17 million years ago, and the Columbia River is flowing somehow through this portion of Washington. We'll probably never know exactly how the Columbia River used to flow through Washington pre-17 million years ago, but the best guess is that it was a semi-straight shot for the Columbia River from BC up by Addy. We have some people from Addy, Quartzsite today, the Quartzsite Tavern, and all the way just cutting right down to Wallula Gap in Tri-Cities. Can you picture that? A straight shot of the Columbia River, more or less, from northeast to southwest, kind of a straight line. I think some of you have heard this before, but what happened starting 17 million years ago? We had cracks opening up, fissures. The fissures opened up, orange Hawaiian-like lava came to the surface, and much of the flooding of the inland Pacific Northwest by Hawaiian-like lavas happened between 16.5 and 16 million years ago. Who cares? Here's why you care. There was so much flood basalt activity here that the Columbia River was pushed up to Brewster. The Columbia River was pushed off of its original course and shoved all the way up to Chelan, shoved to Wenatchee. And if you know that drive between Brewster, Chelan, and Wenatchee, that's still the course of the Columbia River. So 17 million years ago, the Columbia River got pushed up to that trench and it hasn't left. But in every other place, the Columbia River has shifted back into this area that got flooded by lava. including here. Oh, wait, you said I zoned out for just a second. Are we already to making the ridge? No, we're not. We're still just flooding and making, you guessed it, the German chocolate cake here. 300 layers of basalt lava stacked one on top of another. 16.5 to 16 million years ago. These layers in this face are a small portion of the German chocolate cake. And I think we just have a skiff of light that maybe can help us. Can you see, go down the road on our side, there's a car just going over that hump. Up away from that to the right, we have a very angled slope. That's a talus slope, right? Oh shit, we got to get the home viewers here. Hang on. Go up above the steep talus slope. By the way, you're welcome at any time to get up, turn around, walk around, whatever, if you can't see what I'm pointing out. Close to the top of that ridge, can you see a hint of a white layer? And this is not the best place to see that white layer. If you're up high across the river and looking west across the Columbia River, and if the light is good in the morning, let's say, you can see a beautiful white rock layer. That's called the Vantage sediment. That's called the Vantage Sandstone. That's roughly 16 million years old. It's up there close to the top of this ridge. Most of the German chocolate cake is below the Vantage sediment. Some of the German chocolate cake is above the Vantage sediment, but 16 million years is the age for that Vantage horizon. And you're like, okay, I think I see what you're talking about. Not really, but I'll play along. Seems like you're desperate. Yeah, I am. I want you to see it. Now you go, okay, well, isn't that the Saddle Mountains over there too? Sure it is. Well, can't I see the white layer over there? Well, I can see a bunch of white stuff down low. What's that? That's loose sand. That's not what we're talking about. That's sand that's very young, and we'll talk about it in just a bit. We're not to that part of the story yet. But again, things look different on the other side of the river. Roughly halfway up. Not those layers you can see. Okay, so let's just play here for a second. Not the best place to see this, but you see quite a ways down the north face of Saddle Mountains over there. And can you see towards the top there are some tan layers? You can just barely make it out. Privately, I was hoping for some nice strong sun at this hour, this time of year, just coming right over that ridge and just lighting that thing up. I got too greedy, okay? We got rain instead. But yes, there's some white layers towards the top over there. Those are not the same as this Vantage sediment here. All I'm trying to say is, next time you drive Crab Creek, or next time you're on that Royal Slope and you're looking at the north face of Saddle Mountains, maybe if the time is right and the light is right, you'll see the Vantage sediment about halfway up. That matches with our guy here that's a little bit higher than halfway up. But we're part of the story where we don't have a ridge yet. We're just making layer after layer after layer on a flat, featureless location. And each time we erupt a lava flow, we screw up whatever water happens to be in the area. Maybe there's a lake. Maybe there's a forest. Why did I mention that? Now the lava flow comes in, we make petrified wood. That's right. So we're back at that time. What in the hell just happened? We just started this lecture, it starts raining, it's getting stronger and stronger. Look at these hardy people. My God, it's not exactly a downpour, but we're getting wet, baby.
We're good.
Crazy. I hope I don't get electrocuted here. All right, move the story along. Talking to myself. $11.81 million years ago, we have a tremendous event. It's still flat in central Washington. What's the incredible event? The Yellowstone mantle plume is down by Twin Falls, Idaho. 11.81 million years ago. And it does a supervolcano explosion, makes the Bruno Jarbidge caldera, and sends volcanic ash in all directions away from Twin Falls, Idaho, 11.8 million years ago. Not at the very top, but the second to the top layer over there, in other words, the lower of the two tan layers, is that ash that flew through the air from southern Idaho. It's called the Cougar Point Tuff. We have an excellent date. I've already said it 3 times. 11.81 million years ago. That comes from Barbara Nash at the University of Utah, and excellent chemistry to match that layer with southern frickin' Idaho. And I'm not saying a river brought the stuff up here, I'm saying it flew through the sky.
How deep?
30 feet of it. 30 feet of it, you can see it from here. Now I'm not saying it's 30 feet of ash all the way across the Northwest. I'm not saying that. In fact, I know that's not the case. In fact, you can find that Cougar Point Tuff on Interstate 82 between Ellensburg and Yakima, right at the county line. It's like 6 inches thick. You can find it in the Weenass Lake area. You can find it above Prosser. You can find it in many locations in central Washington. It's not 30 feet, but it's 30 feet here. Again, we're before the ridge. So there was some local accumulation, some local reworking of that ash in some sort of basin 11.81 million years ago to get that over-thickened deposit. But that's a common question when I'm with people and we're in Crab Creek drainage, Crab Creek coulee, and they look up and the light is right and they can see all that white tan. And in fact, if it doesn't ring a bell, towards the top of that Yellowstone ash, I am saying that, it's orange. It's brick red to orange. And it just, wow, what is that up there? I'm telling you, it's this ash. Now I did a video up there a couple weeks ago and I got confused about why it looks so red, because some of the basalt on top of it's also brick red, which blew my mind, and I don't know what the answer is. But before that, before 2 weeks ago, I was confident that the Elephant Mountain lava flow, yeah, the one where I dropped my hammer and Drumheller channels, the one with the beautiful Tootsie Rolls, that same lava flow is the top brown layer up high. I don't think it's up here, didn't get this far, but it's over there. And the heat of that Elephant Mountain lava flow 11 million years ago baked the top of that Cougar Point Tuff, welded it, turned it to brick red. Stay tuned, I don't know, there's probably more to that story now that I saw that up close. To finish our story of the rock layers, at the tippy top of the Saddle Mountains over there, I don't know how well your eyesight is. I'm not pointing right here, by the way, you know. These tan layers I'm trying to describe right now, the Cougar Point Tuff, and now this tan layer at the very top, which is known as the Ringgold Formation, is only visible, take 4 bumps down the way, right? Go over 4 humps and then you'll finally get to what I hope you can see from here, and maybe you'll get motivated enough to get over there right below it and look up. That's the Ringgold Formation, 8 to 3 million years ago. Lakes. And again, why would a lake form at the top of a ridge? The ridge wasn't here. There's river cobbles up on top of Saddle Mountains. The river cobbles are quartzites. The river cobbles show that the Columbia River used to flow right over that area. That's now a ridge, but can you mentally get the Saddle Mountains back down? I'm cutting ahead to the story just a little bit. If it's unclear to you, this ridge that's in front of you, that's in front of all of us, behind me, lifted. And to go back in time means we get to get those layers back down to what's beneath us here. Everything we see, can you get it down? Oh shit, what am I saying then? I'm saying there's a fault. There's a major fault that's right at this break-in slope. I can't hold it. I got bored with the layer talk. I got to get to something good. So, do you know what I mean by break-in slope? It's a phrase we use a lot when we're out making maps. We have flat, and then we suddenly change to a rather steep area. It's obvious where the direction you're looking, but if you want to stand up and look backwards, or at least crane your neck, It's more modest behind us, but if you come down the skyline from the upper left, there's bumps, there's bumps. We're coming down left to right, left to right. We get to the power lines, and that's a different topography where the power lines are. And the Saddle Mountains fault is right at the break-in slope. So just mentally with your eyes or with your finger if you want, start at that break-in slope behind you. Basically it's where the brown and the green boundary is, and just follow with your finger right along the base of this slope, and that is a major earthquake fault. And you're like, well, that doesn't sound good. Should I be nervous about this? I've never heard that before. I read geology all the time. I've never heard of something called the Saddle Mountains Fault. Well, you're getting to me right now. We don't know much about the Saddle Mountains Fault. We know a little bit about its history, but we don't know the most important thing, which is, how active is it? How big are the earthquakes that are generated by the San Andreas? Whoa. I just called it the Seattle Fault and then the San Andreas Fault. Now I want to call it the actual name, the Saddle Mountains Fault. It's active. We're pretty confident of that, meaning that it's not done making earthquakes. So that's the headline. And then you want to read the articles, like, okay, so like how, when? We need to do much more work on the Saddle Mountains Fault, hopefully find layers that have been broken by past earthquakes on this fault, get a date for each of those broken layers, do some basic math to figure out what the average number of years is between broken events, earthquakes, and then project to the future and talk about risk. That work hasn't been done. But that gets us to the last part of the main geology before I get to the Ice Age floods. How am I doing? Okay. So Lydia Steisch is a geologist who started with the USGS a few years ago, and her first major assignment, she was based out of Menlo Park in the San Francisco Bay Area. Her first assignment was to come up here and do this, to work on this Saddle Mountains Fault. Like, we got to figure this out. Just generally, when you look at a land, I'm getting excited now, just when you see that landscape with such an incredibly steep face, that's youthful geology. That's not a place that's been quiet and dead for millions of years. It would have eroded off, it would have somehow kind of gotten itself muted. That's not muted, that's about as fresh as things look. So we have an active fault surface. So my point is, Lydia Steisch showed up, and what do you do if you're an earthquake scientist or a structural geologist? You start working with the rock layers. Well, we know them now. Columbia River basalt lavas, Vantage sediment, what's the age? What's above some of those basalts? Cougar Point tuff, well, I got the date, 11.81. What's above that? Elephant Mountain flow, 11 million years ago. What's above that? Ringgold, 8 to 3. Then she comes this way, and she starts looking at the rock layers. Can you see a hint of it? So Crab Creek is the major drainage that's coming at us along the base of the north face of Saddle Mountains. And we can see just a hint. I wish I could zoom for the home crowd. We've got just a hint of the other side of the Crab Creek coulees, as it's called. Those rock layers are at the top of Saddle Mountains. I'll say it again. This is not layer cake geology through here. I just got done describing the fact that we have a huge fault between the ridge and us, or the ridge and the other side of Crab Creek coulee, which therefore means we just can't take these layers and project them horizontally. What I tried to say awkwardly, and I'm going to say it again now, hopefully beautifully, is that once upon a time, my two hands were together. Earthquake on the Saddle Mountains Fault, doink, earthquake, doink, earthquake, doink, earthquake, doink, doink, doink. That really showed up well on the camera. So the Elephant Mountain basalt lava flow, which is the top brown layer on top of Saddle Mountains, is the one that's visible down here low. Or if that doesn't work for you, let's work right here. We just decided there's a major fault here, right? So are we sitting on the basalt layer that is at the base of that talus slope? The answer is no. We're going to do a bunch of doinking again. So our layer is at the top. Or maybe now that I say that and I think a little bit more about the geometry, I think there's been so much action here that our layer is gone. It's not only, it was at the top, but the uplift continues, and uplift intensifies erosion. So it's that layer, that white layer that some of you are pretending to see because you're nice people. It's called the Vantage Sandstone. Why? Because it's at Vantage. So there's our white layer that used to be continuous down here below us, and now it's up there. Yeah, the Vantage Sandstone is below us. That's another way to say it. That white layer up there is below. We're not on it, it's below us. So the geometry of this is quite exciting and also slightly daunting if you're kind of a nervous person. So I don't know, I hope to be doing this another 20 years, Will we come up with some new data and realize that these faults in eastern Washington are way more active than we think they are now? I would bet on it, but I don't know. We have mappers working on it, so hopefully we'll continue to learn. Okay, Ice Age floods. No, two things, and then we open it up to questions. To finish the Lydia Stice story, she came to learn about the layers, and then I started doing all the hand stuff and I got distracted. And she got distracted because as she started sampling and studying the Ringgold Formation, where is it? It's the top tan layer over there, 8 to 3 million years. She started making sand, she started collecting sandstones from the Ringgold, bringing it back to the fancy labs, analyzing the details of the sand grains in the Ringgold, which is where? At the top up there, but also at the base down low. It's also at the top of Smyrna Bench, if you know Smyrna Bench. And she made this incredible discovery and published on it 5 years ago. The discovery was much of the sand in the Ringgold Formation here matches bedrock in southern Idaho. And that sand was brought by a river. And her dates, her sand dates, were older than 5 million years ago. So it's going to get a little funky here for just a second. I'm warning you, if you've never heard this before. It's going to be hard to visualize, but I'm going to try anyway, okay? Well, just make the statement first. Hell's Canyon, you know where that is? Hell's Canyon, Snake River, deepest river gorge in North America. That's the Snake River cutting between Idaho and Oregon. Hell's Canyon started to carve 3 million years ago. That's a whole nother topic. But conventional wisdom is Hell's Canyon and the Snake River started to cut Hell's Canyon starting 3 million years ago. And yet Lydia has the Snake River bringing sand to the Saddle Mountains in central Washington 5 million years ago, 6 million years ago, 7 million years ago. And over the last few years, her peers who've been working on these problems basically said, I'm pretty sure that's impossible. I don't think you have Snake River sand. I think it's something else. It can't not be the Snake River bringing that material here. Today and tomorrow, she's in central Washington continuing this work. So it's an ongoing thing, but she did publish this Snake River paper last year. And earlier than 5 million years ago, she has some maps with her data, and she has the Snake River getting to us here without going through Hell's Canyon.
Wow.
she's got it going from Pocatello, Idaho, north into Montana, basically going up I-15. I'm talking about the Snake River earlier than 5 million years ago, coming up through the panhandle of Idaho, coming into northern Washington, the Snake River earlier than 5 million years ago, and the Snake River is coming down towards the Saddle Mountains and bringing that sand. And you're like, bullshit, I don't see how that, no way. She's got good data, and she's continuing to work on this story. And we don't want to go crazy on this topic, although I think it'd be fun to do it at some point. But you're like, well, just how are you going to get a river going like up and over, you know, Monida Pass and these other things? It's like, we're older than 5 million years ago. The ridges aren't there. You can change the ups and downs. You can change the topography if you have that much time. And she's developing this data set of these detrital zircons with these Snake River sands getting this in. So if you talk to Lydia Steisch and a handful of others who know how to read her data sets well, they really feel strongly that there's Snake River, we're looking at Snake River sand that's now at the top of Saddle Mountains, but you know what we need. We got to get that ridge back down. Last pre-Ice Age floods thing, I'm getting carried away. There's debate about when this ridge started to pop up. Some of the mappers 30 years ago said, okay, make all the German chocolate cake layers. Let's get to about 10 million years ago, still flat. And then 10 million years ago, let's just start to knuckle this ridge up. Let's just have it knuckle up. Let's have it fold. Do the clockwise rotation and squeezing the crust. And it's just a gradual ridge forming thing, not just this one, of course, but all these ridges in central Washington. Next group of people say, well, if you look carefully at the geometry inside of this ridge, it's not just a simple knuckle. It's a knuckle, it's an anticline that also has a major fault at the base of it, and that fault is low angle. If you were at the pop-up last fall in Stone Rose, I was doing this. Or Stonehenge, right? Stonehenge. I have a kind of a low angle fault, the Saddle Mountains fault. I didn't give you a geometry, by the way. Maybe you just imagined like a vertical crack. Now I'm giving you a little bit more geometry that we know. The fault here is not straight down, but it's low angle. And therefore, as you squeeze Washington horizontally, you knuckle originally, but then you break it and you shove this set of knuckles up the fault plane. So the visual I'd like you to have is that, God forbid, if we have a magnitude 7.3 earthquake this evening, this ridge is going to come at us. It's not going to go up, it's going to come at us on this relatively low angle fault plane. Lydia has data from the Ringgold to say, okay, I'm actually going to use my notes this time. She's got a precise date when she has a change in the Ringgold formation, which is we stop knuckling and we start actually breaking and therefore accelerating the uplift of the Saddle Mountains fault. 6.79 million years ago, Lydia Steisch, in her 2017 paper, thinks that we really start to uplift the Saddle Mountains. If you talk to a guy like Sky Cooley, who works with calcretes, he doesn't think there's a major ridge until 3 million years ago. And then it's flat up until 3 million years ago, and then we just have an ice age uplift. So this is also part of the story that's currently being discussed back and forth. I finished the story with the Ice Age, of course. And for many of you, you love the Ice Age floods, and you thought we were doing nothing but the Ice Age floods here. We could do a whole thing just on the Ice Age floods. This is a major hole. By the way, am I saying that this ridge was intact and then something broke through to make this gap? No, I'm not. If you've been paying attention the whole way, we said the river was here first when the area was flat, And I hope you see that these ridges have grown on either side of this Columbia River. Forget about the Snake, just the Columbia River. From Bjornstad's book, a couple of kernels, and then we'll open it up to you guys for questions. I can't thank you enough for this energy. I just want to pause for just a second. Like, this is just a dream to have everybody out here, number one. I haven't been arrested yet. And just thank you. And just to have, you can, it's like that magical silence in a classroom too. Like, there's terrible silence, but there's also like really electrical silence. I think you maybe know what I mean. And that's out here among the crickets and the raindrops and everything else. So thanks again. I think you know the Ice Age story begins about 3 million years ago, and most of the drama of the Ice Age floods that we know about is younger than 20,000 years ago, so it's very, very recent. These Ice Age flood stories are powerful to a lot of people because there's a lot of familiar landmarks now. Our ridge is up during the Ice Age floods. That gap is there during the Ice Age floods. Like, you know, if you just magically like come out of the sky and check all this out during the Ice Age, like, oh, I know that, I know where I am. There's landmarks. If we come back 10 million years ago, there's no landmarks, it's Nebraska. Okay? So, not the greatest place to see, but there is a flood bar called the Beverly Flood Bar. It's a pile of gravels about 150 feet thick. Some boulders, mostly cobbles. I noticed a couple of erratics in here. They're mostly kind of what we call crystalline rocks, meaning granites and metamorphic rocks. Boy, I really want to say something right here. Maybe I'll just save it. So a lot of crystalline rocks that are piled up on both sides of the river. The little town of Beverly that we can see, all those green trees, it's built on the Beverly Bar, the Beverly Flood Bar. Who cares? Well, there was Ice Age floodwater coming down Crab Creek, for sure. Major Ice Age floods that came over Dry Falls, filled Quincy Basin, through Drumheller channels, and as that Ice Age floodwater is leaving Drumheller channels, a bunch of the floodwater gets sent down Crab Creek Coulee, comes at us. But not all of it. Some of the Ice Age floodwater coming out of Quincy Basin over Drumheller channels headed east over by Othello and skirted around the far end of Saddle Mountain. Some of you know that if you follow this, Saddle Mountains gets wimpier and wimpier as you go east until it disappears to nothing past Othello. So is there Ice Age flooding here? Absolutely. Right over your chairs, coming down the Columbia Valley. We were talking about that at the last pop-up up by the erratic near Ginkgo Petrified Forest State Park. But the new wrinkle here is that we have a lot of Ice Age floodwater coming at us along the face, the north face of Saddle Mountains. I'm finally to my point. The last major flood in this scene had to come down the Columbia. You know why? Because the Beverly Bar is continuous across the mouth of Crab Creek Coulee. It's been cut out a little bit by the modern Crab Creek, but basically the fact that this pile of gravel is 150 feet thick that seals off the mouth of Crab Creek Coulee means that we didn't have one last major flood coming out of Drumheller. Instead, we had it coming down here. A couple other notes and I'm done. This is a huge gap. It almost certainly was narrower before the Ice Age floods. I think that's a safe statement to make. We have a hell of a lot of water trying to get through this gap, and that sounds familiar, doesn't it? The more famous gap is called Wallula Gap, which is at the south end of Pasco Basin. This is the major gap on the south end of Quincy Basin. Rob from Salem, Oregon mentioned before we started, he said, I just looked at Google Maps. I think this one's wider than Wallula Gap. Is that true? I'm like, I've never heard that. Maybe it is. I don't know. He said, I just eyeballed it, but this looks like almost twice as wide as Wallula Gap. So somebody at home, can you look at that? Can you measure it on Google Maps? I mean, I'm curious if that's true. But regardless, we had water waiting its turn to get through this gap. I think we can all agree on that. There were major ash floods coming down the Columbia Valley. And that water's all trying to squeeze through this gap, which was presumably a little bit narrower during the Ice Age time. Many times. So what evidence do we have? Well, I'm tempted, but I don't think I've ever seen it and documented. I'm going to say it. I'm not afraid. If you have a lake during the Ice Age and the lake is persistent, you develop beaches or shorelines. I don't know what the elevation of those faint horizontal lines are. I'm almost regretting saying it now in the middle of my first sentence. I think we're too high. I'm not sure though. What I'm intrigued by with this light do you see what I'm saying about halfway up? We have these kind of landforms that look like they're kind of horizontal. And again, we're not doing it like you should, but it's a first thought, like, are those old beaches of a lake as the Ice Age floods were waiting to get through? Let's not get hung up on that. That must have looked like Brett's or somebody, I don't know. The main storyline with why there aren't big beaches here or any evidence of a long-lived lake is because there's two main ways to go for this flood water. This is different than Wallula Gap. All the water has to get through Wallula Gap every time there's an Ice Age flood. Whether the water's coming from Canada, wink wink, or it's coming from Montana. But here, as I just mentioned, if you're still with me, we have a lot of water coming towards Saddle Mountains, and a bunch of it's going east and a bunch of it's coming through here. So we have an outlet. We're not going to have a huge backup of water in here. Probably we had some, but not a huge amount. There's ice rafted erratics through here as well. And if you wanted just a rough idea of how deep the water was with some of the major floods, I think we're going to use 800 feet again. I think we can go about a halfway up. From the base to the top of that ridge, I think with some major floods coming through Sentinel Gap, I think we can imagine water that's inundating half of what we see, halfway up. But it was so quick and so short-lived that we don't have well-developed notches or other features. Brett's apparently, you know the name J. Harlan Brett's, was in here a little bit. This is not a famous place that he worked. But apparently Brett's is reported in his notebooks or maybe on his maps that in Sentinel Gap itself, there's a very deep hole. And it makes sense if you think about it, but I don't know how in 1922 or 1924 he would have that information. But there must be some bathymetric maps pre-dams. You know, Wanapum Dam was built in the early 1960s. I didn't say it, but this bridge was built in 1909, and the last trains on this bridge were 1980. There's a lot of human history here, but there's Ice Age floods history here as well. So, what's the main message? There's a lot going on right here, and I've done a lot of field trips and other kind of programs and things here because there's so much to mentally get your mind around. I'll leave it up to you to decide how much of that you absorbed today, but that was the attempt without one map, one drawing, or one photograph. That's the end of the program, everybody. Thank you. Thank you. First question, what's up with the sand? So I've never seen careful formal studies on the sand, but I've been on enough geography field trips with Carl Lilquist to have the main story. If you look at the composition of that sand, I'm talking about these blonde sand dunes, right? They're not on this side of the river, they're just on that side of the river. If you look at the composition of that sand, it's not basalt. It's not brown sand. So as a geologist, you're like, okay, this is like crushed granite or crushed gneiss. There's no bedrock here that's crushed granite or crushed gneiss. We got to go way upstream. So my short answer is, before the dams were constructed on the Columbia River, there were a lot of sand dunes on that side of the river. Some of the old timers maybe can verify it for us. Back in the 1950s, a bunch of sand dunes to climb around on. There's still some. But that sand that was brought down the free-flowing Columbia River before the dams were constructed. And then we know it's a windy place, and so the wind on the exposed floodplains is going to blow that granitic sand, that crystalline sand from up north, and blow it up onto the wall. Is there still sand coming down the river? No, because we've dammed the river. So that highway of bringing blonde sand has been shut off. As long as the dams are here, we won't bring any more of that blonde sand. So I don't know, in the next century, is that stuff going to continue to get blown up, and then finally out? I don't know. But that's my story, and I think it's the conventional story on those Beverly sand dunes. Okay, let's go. Let's make it nice and rapid fire. Yes, way in the back, sir.
Mattawa-Boulderfield.
Mattawa-Boulderfield, thank you. More of a statement, really. I got you. So a common question generally when you talk about the Ice Age floods and you talk about all these columns that are lifted up by the floods and then taken away, what's the common question? Well, where'd it go? It didn't evaporate, so where can I find those busted up columns? One answer is the Mattawa-Boulderfield. So if you want to go down after this, if you're heading south, go to the little town of Mattawa, which is on the other side of Sentinel Gap, hang a right at the roundabout, then hang a left at the dead end, and if you haven't done that before, there are hundreds and hundreds of boulders just out in the field. Too many to move, too many, just, oh, what are we going to do? I guess we'll graze cattle in here or something. And there's some public land, some fish and game land where I take my students typically. There's one beautiful, big, metamorphic erratic, but the rest are all basalt, mostly. And I visualize those basalts in the Mattawa-Boulderfield as being ripped off the walls of Sentinel Gap, or broken pieces of the Tootsie Rolls at Drumheller, or some of the columns at Frenchman, the crinkle-cut French fries. So that's an example of many places where there are boulder piles, and you're like, well, why did the boulders get dropped on the other side over there? I think you know the answer. When you have water through a gap, it's fast, and once you get the water to the other side of the gap, the water's going to slow down and spread out and drop everything it's carrying. And that's true with any narrow constriction, even in the Columbia River Gorge all the way to Portland. Every time you go through a narrow spot like Rowena, just go past that and you'll find a bunch of boulders being dropped. Thank you.
Why was the gap spared from being lifted?
Why didn't the gap just get lifted?
Why didn't it get lifted? Why is the gap there?
So the gap itself,
the river didn't make it.
So
why didn't it? No, the river didn't.
So the river was here first when the area was flat. And let's get the river right in this position. And then we start our squeezing and our knuckling. And as we knuckle and shove and shove and knuckle and shove, the gap just gets bigger and bigger and bigger. It's a river holding its own. Just imagine the river as a knife, and let's lift a cake against the knife. We're still going to form that gap, but we're going to have the gap be a result of uplift against the river. So that gap was fully formed, probably narrow, but fully formed before the Ice Age floods. More? Yes. Yes.
Saddle Mountain is just above Vantage on the east side of the river. Those are white quarries.
Yes.
What is that and how did you get there?
Thank you. So question is about the diatomaceous earth and the quarry of very white layers. I failed to mention that we can see some of the Frenchman Hills across the way here. So Saddle Mountains to the south of us, Frenchman Hills, which are kind of subtle, not a great view from here, are above Vantage. The answer to that question is we're back at the lava flow time, and after one lava flow eruption, but before the next, we had a lake, and we had diatoms falling to the bottom of that lake and creating that impossibly white styrofoam material. So it's a sandwich of an ecosystem between basalt eruptions. So it's a white layer within the German chocolate cake. And it just happens to be at the surface there and mined for abrasives and cleansers and other things. But you can follow that layer through central Washington as well.
Is that the white layer at the White Bluffs down above the Tri-Cities?
The white layer at the White Bluffs down by Tri-Cities across the river from Hanford, that's the Ringgold Formation. So that's up on top. So this does get confusing. I'm thinking of Tom Foster, who I used to do programs with, and he really wanted to do a program on white layers in central Washington because his gut feeling was everybody's thinking all these white layers are like the same one, or like, you know, what's all the white layers? And it is difficult to kind of put these all together. So the White Bluffs match with the very top here. The diatomaceous earth match with nothing here. The Vantage Sandstone matches with what's underneath ginkgo petrified forest. The white layer that's second from the top up there matches the Bruno Jarbidge caldera in Idaho. Ooh la la, give me a break. Way in the back.
I'm curious about the Pocatello caldera blowing material this far west when everything, with the prevailing weather and everything, is going to be pushing it east.
Thank you. Yes, the question is basically, why would you have ash coming north or northwest from southern Idaho during that event, that Cougar Point Tuff event? And the answer is these supervolcanoes are so impossible to visualize that weather is the least of the concerns during that eruption. So we have no massive supervolcano explosions in recorded human times to comprehend the scale. But I am talking about the modern Yellowstone National Park, and the last time that exploded was more than 600,000 years ago, and we have that 600,000-year-old Yellowstone ash 100 miles in all directions, not just downwind. So it's that scale of volcanic explosion that allows the ash to come up here. I agree. If we think of St. Helens or other volcanoes we can think of, there's just this little sliver of ash downwind, but this is a different animal entirely. Yes, yes?
When was the last supervolcano explosion in the world?
Well, I got in trouble with this one. I did a lecture downtown, and I was very definitive in saying humans have never seen a supervolcano erupt, and I think generally that's accurate, but the people in New Zealand weren't happy with me. I still haven't done my homework on that. Tapao, is that it? I think 70,000 years ago, and we do have some early human occupation at that time. So, you know. So I think that's the answer. 70,000 years ago on the other side of the Pacific, there was a supervolcano.
But not for that long.
Right. Let's keep it going. And if you've had enough, don't feel like you're locked up here. You don't have to stay till the very end. Yes?
If Lydia Steisch and Sky Cooley think that ridge raised faster than everybody else,
yeah.
If it did, how was the river able to keep up with it?
Interesting question. So the question is, if we have really quick uplift of these ridges, how is the river able to hold its own? So I'm pausing because there's different ways to answer that. It's a good question. So we have examples. Okay, how am I going to do this? So we have examples in central Washington where a river was flowing and the ridge was uplifting too fast, and the river said, screw it, I'm going somewhere else. I cannot keep going this direction. One example is Sunnyside Gap. So this river, this Columbia River, used to cut across, what ridge is it? Is it Toppenish Ridge? whatever the ridge is where Sunnyside Gap is today, that's Tanum? Rattlesnake? Rattlesnake, thank you. So Rattlesnake Ridge history that we know is an example of a ridge that grew so fast that the Columbia stopped going straight to Sunnyside, and instead it started taking a left along the north face of Rattlesnake Ridge. So that's an example of the ridge uplift defeating the river. Here we didn't have that. Okay, I'm pausing now too because, good question. Thinking in real time with you all. So there's something called the Snipes Mountain Conglomerates, which are best exposed over at Snipes Mountain over by Granger, Grandpa Carl's place. But there's some of those Snipes Mountains conglomerate on the back side of Saddle Mountains. If you've ever driven from Mattawa and driven to the top of Saddle Mountains, there's some cobbles, some river cobbles, some quartzite cobbles on that road towards the top, which I said casually here, but I'll be more careful now. What's the date there? 8 million years ago, the Columbia used to flow, I'm going to make up a number, 10 miles further to the east. The Columbia River used to come straight south and go right across what is now Saddle Mountains 8 million years ago. When they were either lower or not there. And then we start our knuckling, we start our faulting, we lift, and the Columbia River says, I'm going to come over here instead. So you can see even in my basic statements, where at the beginning of this program I said the Columbia River is the oldest, I mean that. But I think I'm realizing right now with you that the Columbia River hasn't always gone right here for 17 million years. It worked its way to this location, oh shit, since 8 million years ago. But it's still a story of uplift against the river. Oh, you can see how this stuff is. Applause for a confused gentleman in front of a camera. How about 3 more as a group, and then we can talk in smaller sessions here. 3 more? Yes?
Petrified wood up on Saddle Mountain, how is that related to here?
Question is, there's a famous petrified wood layer at Ginkgo. And that's right above our white vantage. We can even see it better now, I think. The white dots close to the top, that's a thick vantage sediment. And right above that vantage sediment is the most famous collection of logs. Like if you want to go up there right now, you can pull out all sorts of major logs that are up there right now. It's a little difficult to get up there though, right? That's military land besides. But if you go to the very top of Saddle Mountains across the river, it's a war zone up there pulling these logs out of the top of Saddle Mountains, and that is not the Ginkgo layer. Where are you? There's other petrified forest layers as well. I can't remember the date, but it's a little bit younger than 10. So there's multiple forests, multiple places within the German chocolate cake, and that's a particularly rich layer of wood that happens to be popular because it's right at the surface and you can get to those logs pretty easily. 2 more. Yes?
Isn't there a large deposit of ash from Manzama down around the corner? And what was that?
There might be. Mount Mazama is Crater Lake, most of us know, in southern Oregon, and that was not quite a supervolcano, but still a big one. And Mazama ash, Mount Mazama ash it's called, 7,700 years ago, blanketed much of the Pacific Northwest. I've lost track of the number of field trips I've been on just as a guest or a participant, and they go, yeah, there's Mazama right there. So that is a marker bed all through. I'm remembering right now, thank you, I forgot about that. On the other side of Sentinel Gap, no, am I remembering that? There is Mazama there around the corner?
I thought you set up on the hillside over there.
Oh, that's the Cougar Point Tuff. That's the 11.81, yeah. There's something else over there that's a little harder to describe. 2 more. Yes.
How far below us is the Vantage sediment?
Kyle Bain. How far below us is the Vantage sediment? I can look across the river right now and I can see Rosa, and I'm now picturing the depth between the Rosa crinkle cut French fries and French McCooley and the floor of French McCooley, which is the Vantage horizon. So it's basically the depth of French McCooley, which is 500 feet? I'm not sure. 500 feet, Kyle. Last one. Please.
So the red brick layer.
Yeah.
Is that the same red brick layer that's over by Mesa? It's like if you drive like Highway 17, it's kind of like the stuff that's like up there. Is it,
Yeah.
Is that the same stuff that you kind of see like along the Highway 17?
Thank you. It's come up a few times since I did that video. So I highlighted this beautiful brick red layer on top of Saddle Mountains, and more than a few, or maybe you 4 times, I don't know. I don't think so. It's like there's a really red layer over by Mesa, Washington. What's another town nearby? You're a delivery guy. Eltopia, Connell, kind of over there, south of Othello. I don't know what red layer that is. In fact, I'm not even sure I can remember that red layer. But it's another example. Like, are all these white layers the same? No. Well, now we're up to like maybe 2 or 3 red layers. I'll give you a semi-satisfactory answer that sometimes you can get a very deep red layer in the basalt, Columbia River basalt stack if you just have an old soil. Sometimes you can get an old paleosol that's typically right above one of these white layers, and there's so much iron there, I don't know why, but that red comes through that way. From what I saw up on that red thing up there, I didn't see a paleosol thing. There was something else. Half of the ash was red, and then the thing that freaked me out was like the bottom part of the Elephant Mountain was like, I was banging on this basalt and it's bright red, and I don't get it.
Even inside?
Even inside, yeah. Thank you everybody for coming this evening. I appreciate it very much. Hats off to you for coming. We survived. Thank you. We'll see you next time. All right. Well, I thank you all for sticking in there. Oh, it's a little past 1 hour. I don't think I'm going to edit the thing at all. We'll just kind of upload it to YouTube, and I'm hoping to premiere this Wednesday afternoon. But why am I saying that? You're not going to know about it till after the fact anyway. Thank you everybody for watching this video. I commonly get asked, what is the pop-up geology schedule? Can you send me the schedule? There is no schedule. That's the whole idea. That I check the weather, I check my schedule, and if it looks like the weather's great and I have a place in mind, I announce this on the YouTube channel 48 hours ahead of time. And that's it. And then people congregate and improvise with their schedule. So if you want to join us for one of these, just keep an eye on the YouTube channel, and I'll post an announcement for one of these. Hope you can join us one of these times. Okay, thank you. I love you and goodbye.